Hello and welcome back to Beginning C++. This week we're going to be talking about constructors as well as a number of other little features of classes and object-oriented programming. So what is a constructor? A constructor is a special function that allows you to sort of initialize and set up objects when they're first created. So however you choose to create an object, right? And we've already created objects last week. But this week, there may be times where you want to do stuff. Maybe, I'm creating a new student. I should probably add them to maybe a collection of students over here, or I should do something, or I should generate a new unique, student ID. Whatever it is you need to do when you create that new object, you can accomplish it with a constructor. Set up default values. Really, one of the primary things that a constructor does is set up initialized values for all of the member variables inside of an object. That's the one thing you need to make sure you do. A lot of other languages will at least do that for you. Strings get defaulted to the empty string. Any sort of numeric, variable gets initialized to 0. C++ doesn't do that for you. It allocates the memory, but if there's something already in memory in that location, it just leaves it there. So initializing stuff is a really great idea. So how do you actually create a constructor? Constructors are declared as public, which makes sense. If you're going to create an object somewhere else, you have to have access to the constructor. Now, I will say there are sometimes circumstances where you want to break a constructor, maybe make it private. It kind of depends when you're doing singleton type stuff, but don't worry about that. There's always going to be an exception to the rule, but in general, they are declared as public. They have to have the exact same name as the class, including capitalization, everything. The name of the constructor has to match the name of the class. They do not have a return value. Strictly speaking, this isn't true. They return something like an instance type, but you don't actually place a return value when you're defining the function. How about that? And they're usually overloaded to handle different types of creation. There are several different ways you can create objects. And so maybe I want to create an object and automatically send you what I want for the values for my initial variables or whatever. And you can do it that way. Maybe I can create a generic object sending you nothing. Maybe I can send you an example of another object, another instance, and you create a copy of that. And so a few of these you get sort of by default. You notice that we've already been able to create objects without creating constructors. And that's because you get sort of an empty constructor, the default constructor, for free. It doesn't do a whole lot. It just allocates memory. But at least it does that, right? So anyway, here is a declaration for a constructor inside of a class. So we're creating our circle class from last time. We're going to create a circle constructor that takes absolutely nothing. This is sometimes called the default constructor. It's the one that you get for free. We're going to create our own custom version. And this is something sort of important. Once you create your own constructor, regardless of how, what your parameters are, you lose your default constructor. Right? You don't have the ability to do that anymore. Because what they're saying is, you're saying, I want to construct objects in this way. And so if you're saying you want to construct it in a particular way, then you get rid of the defaults that are there but automatically, because maybe that's not something you want. So as soon as you create a new constructor, a custom constructor, you lose that default one, which means you may no longer be able to create objects without sending something. If you happen to do like the second example where, hey, I'm going to send you a double. If I send you a double, then I want you to maybe set the radius to that value, right? That would make sense. So I want to create a circle with radius 5. I just circle 5, and I can create a circle with radius 5. The other one is it's a constant. The reason it's a constant is because when you send a circle, like another object, you kind of want to make sure that you're not going to alter that object, right? I want to make sure that my object is protected. You're just going to copy the values. And so we make it a constant, and we generally send an alias to that circle so you can access the values directly rather than trying to create a copy of the circle to send you. It's a little more efficient to just have an alias. As long as it's a constant, then you know that you're not going to change my values. We're okay. So here's the actual constructor definitions. These work just like regular function definitions, except they look weird because they don't have that return value or the return type in front. The return type is blank. They are a member of the circle class, then colon, colon, and their name is circle. It's gonna look exactly the same because they have to be named the same as the class. The first one is the default. It takes nothing, right? And that one, we're just gonna say, well, radius is 0. Now, one can argue whether or not a circle of radius 0 is actually a circle, but it seems like good enough default for now. The other one is, hey, here's another version of the exact same constructor, the exact same function. But this one, you send me a double. If you send me a double, then I'm not going to set the radius to 0. I'm going to set the radius to whatever you sent me, right? That makes sense. It's like, yeah, you're sending me a value so I can initialize this circle at the point of creation, rather than having you go in and try and change the member afterwards. This one is kind of a little bit weird. This is the one where you're sending another example of a circle, right? So if I send you an instance of a circle, then what we'll do is we're not going to touch that original circle. It's, constant, but we're going to go to it, src, source. So then I'm going to set my radius to whatever the source's radius is. So if you send me, create a circle and you send an example of a circle that has a radius of 3, I'm just going to copy that radius of 3 and make it the same as mine. So this is my copy constructor, which, by the way, you also get for free in C++, until you create your own custom one. So here's actually using constructors. There's lots of different ways to do it. Circle A, I haven't called anything. I didn't use parentheses at all, right? But that is still going to call my default constructor. But now we have a custom default constructor, and that one is going to set the radius to 0. So circle A will have a radius of 0, right? Because we've already defined that behavior. Circle B will have a radius of 4 because I'm sending a value. Now, I said I was going to send a double, and what I actually ended up doing was sending an integer. That's fine. C++ is okay doing implicit conversions from integer to double or double to integer, sometimes without you realizing it, which is a problem. More modern languages sometimes try to prevent that, but in C++, that's perfectly fine. Circle C is going to equal a new circle with radius 6. Here I'm actually calling the constructor by name. I'm not using some C++ shorthand. I'm also using that new keyword, which is actually going to create it in a slightly different way. Remember when we were talking about pointers and using the new keyword, what I'm actually doing is creating that circle object in the heap. Because it's in the heap, it's not part of the function or the call frame for that function that we're in, which happens to be main. So if it's in main, it doesn't really matter. But because it's not there, like if I create an object in a separate part of memory in the heap, then it will live on past this function, right? Except this function is main, so it's the last one that gets called. But like, let's say this is a different function. After that function was gone, that object would still be there. And so long as I didn't lose a copy of the reference, so long as I knew what address that circle was located at, it can sort of survive multiple different function calls. And so that's sort of a nice thing for something you want to stay persistent, to use the new keyword and put it up into the heap. There's also a way you can do it with just states. But anyway, that is a solution that is often used. The last one is using our copy constructor. So our copy constructor is, I'm creating circle D, but I'm sending it circle B. So circle D is going to have a radius of 4. You sent me an example of a circle. I'm just going to copy those values and use them for my new circle. A destructor is not like a constructor. It's not the opposite. And this is probably one of the problems with the word destructor, is that you'll think that this is actually what destroys your object. Right? This is actually the function that's going to get rid of your object, but it's not. A destructor is the function that gets called right before an object is destroyed. Right? The object is going to get destroyed when the call frame gets pulled off the stack. An object is going to get destroyed when somebody calls delete on that object if you created it in the free store, the heap. So if you're using, somehow, there's another thing that's going to kill your object, right? It's going to destroy it. But right before it does, you're going to get this call. And the call is going to be to your destructor for that object. And it's going to say, hey, is there anything you need to take care of? This is a morbid example, but it's kind of like, yeah, if you know you're going to die, can you get your affairs in order, right? It's that last little bit right before the end. hey, I'm about to destroy you. You're about to be pulled out of memory. Is there anything you need to do? Now, why is that important? Maybe there's something that keeps track of the number of total students, and I need to make sure that I decrease that number by 1 because I'm about to go away. Maybe I have other objects inside of me, right? So like a class could have other objects that it references inside of it, right? So maybe for a family type app, right? I've got a parent, and I've got pointers to all of our children, maybe an array of children objects. Well, if I delete the parent, I haven't necessarily deleted the children. The children are located somewhere else in memory. But what I've done is I've lost my reference to all of those kids, and I've created a memory leak, right? I've got objects that I no longer have references to because I deleted the thing that had the references. So in that case, I might want to go in and make sure I delete those objects before I allow myself to be deleted. In which case, when I call delete on those child objects, those objects are going to get their destructors called, and they can handle whatever objects they have inside of them, so that we don't end up losing, or we don't end up wasting a bunch of memory. So point being, that's the point of a destructor. A destructor is for you to sort of tidy up before an object goes away. So destructors are going to look a lot like constructors. They are declared as public. They have the same name as the class, but with a tilde in front of it. A tilde is the little thing you put above an N to make it an enye. They do not have a return value. They cannot be overloaded. Unlike constructors, there's only going to be one destructor. And they cannot have parameters. The system's not going to send you any information. So if you need to take care of stuff, you're going to need to just know what it is you need to take care of. So this is what a declaration for a destructor looks like. Looks just like the looks just like the default constructor because it can't have parameters, but with a tilde in front of it. This is us actually defining or implementing our destructor. So here we've got circle, or it's a member of the circle class. It's called tilde circle. And here I'm just, printing something to the screen, right? Not a whole lot, but you could be, again, getting rid of objects, lowering a count somewhere, maybe sending a message to another object that, they need to get rid of their reference to you, whatever it is. You are handling whatever it is you need to do right before the end. So that's it for destructors. Honestly, you never really call a destructor, and so until you start really getting more complicated objects where your objects have relationships to other objects where you may need to figure out what you're going to do with those relationships, right? Like if I delete a student because they disenrolled from the school, I should probably go into all the classes where that student was located and withdraw them from those classes, right? You kind of get the idea. Whatever it is you need to take care of for your objects and its relationship to other objects especially, we need to handle in the destructor. So this is another concept. It is a keyword that you can use when implementing functions that are part of a class. And it is a reference to the object that function was called on. So if I'm defining, here I've got, an area function. Well, the area function is going to, it's going to use the radius of that object that you called it on to calculate the area. Now for radius, because there's no real conflicts, I could just use radius in the function and that would work. But I can't call functions from an object without using this. And sometimes I need to actually use this as a way of referring to that object you called the function on. So here, this would be a pointer, and it's a pointer, so we're going to use arrows and stuff. It's an actual address. We can dereference this, for instance. But it's a pointer that points to the object that this function was called on. That way you can generically write code for your member functions that can reference the object. So here where I say searchZone.area, when I say this is a pointer to the object called searchZone, right? It points to whatever object is to the left of the dot when you called that function. But when I'm defining the function, I can be super generic. I just know, hey, whatever object you called this function on, I want to do this thing to it. So here, because area is a function, right, I have to find some way of actually getting to the function. I can't just say area with 2 parentheses. I need to have an object to the left. Well, here I'm defining a new function that returns a bool, and it's called is bigger than. And so you send it a circle, and it'll tell you if your circle is bigger than the other circle. And so to do that, I need the area. That's how I'm choosing to, compare circles. And so I can say return this arrow area with parentheses because I'm making a function call. So this is going to refer to the object, the circle that you called is bigger than on. And then is that greater than other dot area? Now remember, other is not a pointer. Other is actually a reference to a variable or to an object. So I can just use dot notation for that one. Since this is a pointer, I have to use an arrow for that one because that'll dereference and then access the member. But here's just another way I can refer to the object that you called the function on. Next concept, static class members. So far all the variables we've talked about inside of a class are all associated with the objects inside of that class, right? So again, baseball player versus an actual instance of a baseball player. The baseball player class has member variables like name, position, team, stuff like that, right? So I can say, Buster Posey, catcher, San Francisco Giants. But at the same time, there may be some things that I don't want to store in every single object, right? Because all three of those things, we sort of drilled home last week that like every single object you create gets those three variables. They're going to have slots available so that you can put in custom values for every single member of a baseball class or a baseball team. Baseball player, sorry. But sometimes you want to have something that's associated with the class, right? So for instance, the total number of baseball players in the league. Well, that doesn't make sense to store with every single baseball player object, right? I'd want to do it elsewhere. See a better example, right? Students. If I had a student class and I was creating a student object, it makes sense that every single student needs to have a slot to hold their own name because you all have unique names. You have to have a slot to hold your major because some of you have the same major, but you all have different majors, or the ability to have different majors. A slot to hold your GDP. You don't have a GDP, you have a GPA. A place to hold your GPA, right? Because that's all unique to individual members, or sorry, individual instances of that class, of class student. But the total number of students at Fresno City College, that doesn't make sense to store with every single object. I only need to store that once. So what I can do is I can create a static class member. So static members only have one. They're not located in an object. They're located in program memory. But they are a place to just hold a value that is sort of shared amongst all the instances, or the way I prefer to think of it is associated with the class itself. And the reason I say that is because it sort of makes sense, right? If I go up to a student, it makes sense for me to ask that student, hey, what's your name, right? Because students know their name. Name is something you associate with an individual student. What's your major, right? That's another thing we associate with an individual student. What's your GPA? That's associated with an individual student. How many students are here at Fresno City College? Why would you know that? That's not something we associate with an individual student, right? I would go to A&R, which in this case is sort of our class, right? Admissions and records, who actually create the student objects, and ask them, hey, how many students have you created? How many students are currently enrolled? Because that's something that they would know. So it's something you associate with the class rather than with an instance of the class. In those cases, you'd want to create a static class member. It's only going to be one value. You would access it through the class itself, or you could access it through any instance of the class. That's something that C++ does, and different languages have different ways of doing it. In Ruby, we would say that we have instance variables and we have class variables. Static class members are just class variables. They're things you associate with the class rather than an instance of the class. If I wanted to keep a roster of like every student who's enrolled, like just a reference to all of those different objects, that makes sense to keep track of in A&R with the class, rather than have every individual student have an array that has a reference to every single other student in it. That doesn't make a ton of sense. So if you only want to store one copy of something and you want it associated with the class or something that all instances of the class can share, you want to create a static class member. The way you create a static class member is just to put static in front of it. So here I have another integer circle count. It's going to keep track of the number of circles I created, and I made it static. So there's only going to be one. It's associated with the class, not with anything else. And there we go, we've declared it. Now, normally you would initialize variables in a constructor, right? The problem is this is a static member. And so until I could theoretically do that in a constructor, right? But I would actually have to create an instance of the class before I actually initialize that value. If I try to reference circle count before I actually created a circle, I will never get 0, or at least there's a good chance I won't get 0, because that value was never initialized. So where do you initialize static members? Weirdly, you do it in the implementation file for circle, where you're putting all of your sort of implementations for your functions or your function definitions. And somewhere in there, you just have a line that says int, it's a member of the circle class, it's called circle count, and we're going to set it to 0. Again, most other languages nowadays make this a little bit easier, but this is C++'s way of doing it. And so, yeah, you just add it to the implementation, and you initialize it there. So then, if I wanted to actually access that static variable, what I would do is I would just reference it through the class. So here I do circle, : circle count, and that will give me access to the circle, and I can print out the total number of circles I've created. Now with C++, you can actually also do that with any circle you've created. If you have a circle A, I can see a.circle count, and it'll give you the circle count. C++ makes it so you don't have to use the class. You can actually use any of the instances. They all share the same reference, but I prefer to think of it as, don't ask an individual circle how many circles there are. Ask the circle class itself how many circles there are, because you would associate it with the class, not with an instance. You can also have static member functions. These are functions that kind of work like any other function. But again, you call that function on the class rather than on an instance of the class. In fact, you can't even assume that an instance of the class exists yet. You may call this static member function before you actually create an instance of the class. Sometimes you do these for just simple references, like I've got a whole bunch of stuff in a math class, like a class that basically holds all these different, like maybe physics formulas, right? And so that I can calculate the wavelength of something just by, because I have these functions that are sort of built in to either my namespace or to a class. So you can do it that way. But sometimes it may just be something that only makes sense to do with a class. Like, so going back to my student example, if I had a function that basically, if I gave you a major, it would give me a list of all the students who have that major. That's not a function that makes sense to call on a instance of a student, right? Because why would you call on an instance of a student to get a reference to a whole bunch of other students that might actually have a different major than that one? Instead, what you would do is probably make that a static member function that might go to a collection class that it knows about, that might also be static, go through all the different students that are currently active and find all the economics majors and then create that list, right? So static member functions, yeah, you associate them with the class rather than with an instance of the class. And this is the exact same thing. If you want to have a function that returned the circle count, then you might want to, because you can also make these things private, right? They can be private or public. So if circle count is private, then I would have to create a getter, which would be probably static, so you can call it on the class itself. So here I've got something that will actually, a count function that will return the circle count. I just put static in front of it so that anybody can get the circle count by just doing circle : count. And here's me actually using it, or sorry, here's me actually defining it. So in that implementation file, now notice here I had to say static in the declaration. I don't have to say static in the implementation. In fact, you can't. I think it throws an error. Here I'm just defining what that function is. I have to say that it's a member of the circle class, but the declaration will tell the compiler, hey, this is this is going to be associated with the class rather than an instance of the class. Then, if I want to use it, I just use it the same way I did a static variable. Circle colon colon, and then I call the function count on the class rather than on an instance of the class. And so now we're not using that dot notation, we're using that colon colon scope notation or scope operator to show that I want the count that's a member of the circle class. I don't want a different count because there may be, I don't know, a square count or a triangle count or something like that. There you go. And so here we actually define, kind of in our constructors, if we are going to keep track of the count of something, right, we have to actually do that. How do we do that, right? In your constructor, right, you can do more than just initialize all your member variables. Here, I initialize my member variable radius to 0, and then I increment circle count because you just called a constructor. We just created a new circle, right? I could also take a reference to this circle from using this and put it into an array, so I can keep a track of every reference to every circle that I've created. You can do all sorts of things, but for right now, I'm just increasing the count by 1. And I also want to increase the count by 1 if you call a different version of the constructor. So here I've got a version of the constructor that takes a double, so I'm going to increase my count there. You'd also want to do it for the copy constructor, right? So you can use that to sort of grab it. And by the way, if you wanted to, in the destructor, do circle count minus minus, that would also make sense because you just called the destructor, so you've gotten rid of a circle. And you know that's going to be called before you destroy any circles. So here we've got a couple sort of, hopefully this makes sense to you, right? That a static function is going to have a couple things that like a regular instance function will have, but this one won't, right? For instance, there is no this reference for a static function. And that's because there is no instance to have a reference to, right? You're calling this on the class, not on the instance. So again, in C++, it's a little weird because you can call functions through instances, but you don't have a reference to this because the function itself is static. It's associated with the class, not with an individual. So I don't know which individual student you're wanting me to call this function on, right? You're going to A&R, it should be more generic. So there is no this for static functions. They also can't access instance variables, right? If I go up to A&R and I say, student class, what's your major? That doesn't make sense. Admissions and records doesn't have a major. Students have majors. Admissions and records are just the place where we create students. So you can't access instance variables, and you don't have a reference to an instance itself with this inside of a member function. And that is kind of it for this week. We'll add more features as we go on. But again, if you have any questions, feel free to send me a message during the week. Have a great week.